The colossal landmass of India is relentlessly crashing into Asia, creating the world's tallest mountain range. This monumental geological collision continues today, pushing Mount Everest higher by tiny increments each year. Imagine entire continents slowly grinding past each other, reshaping our planet's surface over vast eons. These immense forces dictate where nations rise, where volcanoes erupt, and where devastating earthquakes strike. Earth's outer shell is not a solid, unbroken sphere, but a mosaic of enormous, interlocking pieces called tectonic plates. These gigantic plates, carrying continents and ocean floors, constantly drift and interact across the planet's mantle. Their slow, inexorable movements sculpt the landscapes you see, defining the very geography of nations. Understanding plate tectonics unlocks the secrets behind diverse geological features across different countries. From Japan's volcanic islands to the Great Rift Valley in Africa, these movements explain countless natural wonders. These powerful geological processes directly influence where resources like oil and minerals are concentrated. They determine patterns of seismic activity, dictating which regions experience frequent, powerful earthquakes. This continuous planetary dance shapes coastlines, isolates species, and even influences climate patterns over geological time. Learning about these forces reveals the dynamic, ever-changing nature of our seemingly stable home world. Every major mountain range, deep ocean trench, and chain of islands tells a dramatic story of plate interaction. This fundamental geological concept explains why certain countries are prone to specific natural disasters. The boundaries of these plates are often invisible, yet their impact profoundly shapes human civilization and history. Deep beneath your feet, a convection current within Earth's molten mantle drives the incredible motion of these plates. Hot, less dense material rises towards the surface, cools, then sinks back down, dragging the rigid plates along. Think of it like a giant conveyor belt, slowly but powerfully moving massive sections of the Earth's crust. There are three primary ways these colossal plates interact, each creating distinct geological features across countries. First, plates can diverge, pulling apart from each other, often beneath the vast expanses of the ocean. As they separate, magma rises to fill the void, creating new oceanic crust and underwater mountain ranges. The Mid-Atlantic Ridge, a colossal underwater mountain system, exemplifies this process, effectively splitting the Atlantic Ocean. Iceland, a country famously sitting directly atop this divergent boundary, experiences constant volcanic activity and geothermal energy. But that's not the strangest part. This spreading also contributes to the gradual widening of the Atlantic Ocean itself. Second, plates can converge, crashing directly into each other, leading to some of Earth's most dramatic landscapes. When oceanic and continental plates collide, the denser oceanic plate typically slides beneath the lighter continental plate. This process, called subduction, forms deep ocean trenches and generates volcanic arcs along continental margins. The Ring of Fire around the Pacific Ocean, home to countries like Japan, Indonesia, and Chile, is a prime example. These nations experience frequent earthquakes and explosive volcanic eruptions due to this relentless subduction process. The Andes Mountains in South America, stretching through multiple countries, two continental plates collide with truly immense consequences. Nazca Plate, subducting beneath the South American plate. Wait until you hear what comes next. Sometimes, two continental plates collide with truly immense consequences. When two continental plates meet, neither subducts easily because they have similar densities and buoyancies. Instead, the immense pressure causes the crust to buckle, fold, and thrust upwards, creating colossal mountain ranges. The Himalayas, a majestic range spanning several Asian countries, perfectly illustrates this type of powerful collision. This ongoing impact between the Indian and Eurasian plates continues to elevate the world's highest peaks. Imagine two enormous icebergs slowly smashing together, crumpling at their edges to form towering structures. And then something unexpected happened. Sometimes plates simply slide past each other horizontally. Third, plates can transform, grinding past one another along colossal fault lines, like giant geological sandpaper. These transform boundaries do not create or destroy crust, but they generate immense friction and stress. When this accumulated stress suddenly releases, it causes powerful and often devastating earthquakes. The San Andreas Fault in California, a famous example, marks the boundary between the Pacific and North American plates. Cities like San Francisco and Los Angeles are directly impacted by this active fault system, requiring resilient infrastructure. This constant lateral movement continuously reshapes the landscape of this region, albeit very slowly. Each type of plate boundary creates unique geological signatures, influencing the natural history of specific countries. These powerful, unseen forces are perpetually at work, shaping our world in ways we often take for granted. Understanding these mechanisms helps scientists predict where future geological events might occur on our planet. The relentless movement of tectonic plates profoundly impacts human civilization, defining risks and opportunities for nations. Countries situated near plate boundaries often face increased risks from earthquakes, tsunamis, and volcanic eruptions. Japan, for instance, has developed advanced earthquake-resistant architecture and early warning systems due to its location. Conversely, these geological processes also create incredibly fertile soils from volcanic ash, enriching agricultural lands. The volcanic activity in countries like Italy and Indonesia contributes to their unique and highly productive ecosystems. Geothermal energy, harnessed by nations such as Iceland and New Zealand, provides clean and sustainable power. These plate interactions are also responsible for concentrating valuable mineral deposits found in various countries. Diamonds, gold, and other precious resources are often brought closer to the surface through ancient tectonic activity. The formation of unique landforms, from dramatic fjords in Norway to the vast deserts of Australia, is directly linked. This geological shaping affects biodiversity, creating isolated island chains where unique species can evolve undisturbed. The separation of continents over millions of years led to the distinct flora and fauna observed in places like Madagascar. Even the distribution of ancient oceans and land bridges, influencing early human migration routes, was determined by plates. Imagine the world constantly being rearranged, shifting the stage upon which all life plays out its grand drama. These fundamental geological forces have sculpted the very identity of countries, influencing their culture and resilience. The deep history embedded within Earth's crust continues to shape the present and future of our diverse global landscape. Recognizing these powerful underlying processes deepens our appreciation for the dynamic planet we all inhabit together. Ultimately, Earth's tectonic plates are the unseen architects, constantly sculpting the diverse and dramatic world we inhabit. Their slow but powerful movements determine everything from mountain heights to the very stability of our land. These geological forces have shaped, and will continue to shape, the landscapes and destinies of countries worldwide. Understanding these colossal processes reveals the intricate, interconnected nature of our dynamic planet. If you found these geological insights fascinating, remember to subscribe for more incredible scientific explorations. Hit the like button to support our journey of discovery, and share your favorite geographical fact in the comments below. Join us next time as we uncover another mind-blowing mystery hidden within the world around us.